comes with a valid and a preferred lifetime. So the valid lifetime is how long can I actually use it for.
Right.
So and even it's not just with DHCP. With any address, there's a valid time. So when that valid time expires, I can no longer accept or originate connections with that address. The preferred means as long as it's preferred, I will originate connections with that address. When the preferred expires, I'll accept, but I won't originate. So I mean, there's
like a
a
lease time, sort of, right? Only better.
Sort of, because you also have something called stateless auto address configuration. That's the plug and play addressing. So the router, when the router advertises a prefix saying, hey, this network is using this prefix, part of that advertisement is it has a preferred and a valid lifetime that gets periodically refreshed.
Okay.
So that's where that comes from. And that actually also impacts DHCP. Yeah, there's a lot of, unfortunately there's only so much I can fit
Sure,
now,
sure.
so.
Well, shoot.
Okay, so I kind of like, this is one of those pictures, this is from Owen DeLong from Hurricane Electric, great guy, but I want to ask his permission before I actually publish this on his site since he actually created the picture. So this goes through all the addressing, and I kind of like this because this shows, and this isn't fixed, this is an example. Because like a lot of people will say all ISPs get a /32, that's not true. You can get, for example, the DoD got a /13. So the /32 is a start, but it's not an absolute. So this is an example of how addresses can get assigned. All right, I'm gonna skip through this except one important thing. So if link local addresses are only significant on a network, and I have multiple interfaces, let's say I say ping FE80::1, which interface am I talking about? Yeah, the operating system doesn't know either. So I have something called the zone identifier that lets me specify the interface. So I'd actually have to say ping FE80::1% interface or zone identifier number. Unfortunately, this isn't totally spelled out in the RFC, so it's different for every operating system. And I believe in all Unix, Linux, and BSD systems, it's the interface alias. So like, for example, ETH0, FXP0, FXP1, or whatever. In Cisco's iOS, it's the literal, like, case-sensitive interface name and number. In Windows, there's actually a number assigned, like 12. So in mobile devices, I'm not sure. So each operating system has its own way of doing that. So if you use limited scope interfaces, you have to explicitly specify the interface. Okay, and this is, I don't want to spend another time on this, but I think this is like a good reference. So just so you can see, this is the whole IPv6 address space, and at a high level, this is how it's carved up. So notice that 2000 to 3FFF, that's what's currently allocated globally for using on the internet. So all this huge range here, 4,000 to FBFF, that's a massive range. Right now, it's not allocated because it's not needed. I mean, even for us to go through that first range will take, I mean, probably more than a couple decades. So, but people will say that, you know, because that kind of confused me at first, is you'll hear that, you know, all global addresses always start with 2003. It's not that they have to, it's just that that's all that's been allocated. So hopefully that clears that up for you. All right, I'm going to kind of flip through this, just in the interest of time. I'll just say this is a good reference. I get lots of why questions. So I always like the why questions, you know, like, you know, why this, why that? So in a lot of these slides I try to answer because people will say, you know, when I form the interface ID, this is the bottom 64 bits of an address, you know, why do I do it like this? So when I try to answer the questions about, you know, why it's done, how it's done, all that. So like I said, a lot of this I'll leave as reference material, so hopefully I'll answer questions for you later. Okay, another big thing. So in IPv6, the thought process is a little different. In IPv4, I think of nodes, right? I think of individual nodes. In IPv6, I think of networks. So all networks are /64s. Each network can have 18 quintillion devices, which might sound absurd, but again, the point is, it should be such a large number that I'll never have to change it, which it is. So originally part of the idea with using 64 bits for the interface ID is plug and play. So So if you look at Ethernet, it's only 48 bits. So why 64? Because currently the IEEE, for all the newer interface types, like for example FireWire, and the new one that just came out from Intel that the latest Apple notebooks have and stuff, all those guys use 64-bit interface IDs. So the idea was, I'm going to take that factory ID, and that's going to be my address, just like an IPX or DECnet. That's where that came from. But turns out there's a problem with that, because back in the IPX days, we didn't really have an IPX internet. So if everybody uses a predictable interface ID, that becomes a super cookie, right? It's going to be constant across all networks, which lets me track you. So in order to fix that, we now have this idea of privacy addresses. So a privacy address is totally randomized and changes over time. So the good thing is, you can't be tracked. The bad thing is it keeps changing. Like for example, in Windows, it changes every 24 hours. So if I'm a network administrator and I have a network, and all the nodes on my network change their address every 24 hours, even with dynamic DHCP, that's not exactly desirable. So there is a draft that's working its way through the IETF from Fernando Gant for stable privacy addresses that would fix that. And so far it's been held up, but hopefully there'll be some options for there. But you should definitely at least be aware of it.
So if you're required to like be able to track down a change to the individual who instituted or made the change, you'd have to have a list of every single change to the IP address that
Yeah.
took place.
Yeah, it becomes a lot harder with IPv6.
So has this is already 6, or so if someone is using IPv6, they are already changing their IP
Yeah.
address?
By default, like in Windows and newer versions of Linux, it's on by default. So it constantly rotates, or periodically rotates.
So are the
one solution is DHCPv6 is one solution, but for example, some things like Android don't support it. So
What
there's no
about-
perfect solution yet.
What about things where you have like the SSH from one machine to another, and you keep that connection up? For a long
Generally,
period of time.
well, either dynamic DHCP or for servers, you would usually use a reserved or a static address.
So there is still a concept of a static.
Yeah.
But even from the
IPv6.
client SSHing to the server, that the
Yeah,
endpoints
that's-
are changing on you.
That's a
Right?
good question. You
DNS.
know, I'm not sure.
And the connection is up and active.
That's a
and-
good question,
and
yeah, because,
24 hours hits and you change the IP address, you're done.
I'm not sure if we'll leave it open or we'll kill it. That's a good question. I'm not sure. I've never tried. With V6, I haven't left the connection for more than 24 hours. Well, I haven't where it wasn't fixed. I haven't where it was floating like that. That's a good question. Yeah, you know what? I'll check. That's a very good question. I'm not
It's
sure.
more than a day to answer the question.
Yeah.
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 So follow up on that, are the ISPs currently tracking that information now?
Yeah, they have to. Calia. That's why CGN or the multiple layers of data is so expensive, because now they can't just track the IP anymore. They have to also track the port to uniquely identify you. So the storage ramifications are pretty massive. Okay. Oh yeah, and then of course, one more nice thing about the privacy address is, of course, DHCPv6 was changed so that by default the client no longer uses the MAC address. They use what's called a DUID, DHCP unique identifier. So in the current DHCPv6 spec, you don't know what the client MAC address is unless your DHCP v6 server happens to be on the same subnet, right? So that, yeah, there's still some things that are a work in progress. This is one of them. And there is a draft in front of the IETF to actually have, so relays will actually include the client MAC address so you can track it back. But as an example, though, unfortunately some things are not completely polished yet.
Yeah, for sure. That's a good way to put it.
Yeah.
It makes you a little afraid to jump in, because there's some things that
it's-
aren't handled yet.
That's true, but like I said, but it's tough because it's gotten to this point where we're on the brink of disaster with IPv4. There just isn't enough time to do an ideal rollout anymore. And you know, it's going full bore. So, but I wouldn't say that it's unstable. It's more like there's annoying issues that you have to work around or live with for the moment.
I think, looking at the clock, I think we can do about 6 more minutes max.
Okay. All right, so I'll leave this as a reference, but this kind of goes through some of the scoping, examples of special addresses. Okay, so I like to show this. So from a Linux perspective, right, in IPv4 I have ARP. If you have an IPv6 only connection and you're talking to a bunch of things on, you have a bunch of active network connections and you have some kind of a problem where you can't ping something and you go to look in your ARP cache, it'll be empty. Right, the first time I did an IPv6 only network, I was like, oh yeah, because there's no more ARP. So right now I have to look in my neighbor cache. So it's just to kind of make it real, some of the differences. Another big thing. So in the network world, we have a saying called ships in the night. Ships in the night are two parallel things that don't interact. They're completely independent. So IPv4 and IPv6 are ships in the night. They are totally in parallel. So this is really important. What that means is, let's say I have an SSH access to a system, and I have access control on it, so only certain systems can get to it, right? Because if anybody tried leaving an SSH server on the public internet, right? I mean, if it's up to date, it can survive, but I mean, it constantly gets hammered on. So I usually use some kind of access control to at least limit some of that. As soon as I set up a global IPv6 address that's routable on the internet, does my IPv4 firewall or ACL protect me?
No.
No, totally independent. There's no relation, totally separate. So this is really important to remember, right? So in IPv6, in Linux, I have IP6 tables. And I think most of the distros, I forgot to check on Ubuntu, but I think most of the distros, I don't think they configure an IPv6 policy. I think it's just open. So you have been warned.
Okay, so a customer coming in to hit your website, right? You got firewall rule, and they start using IPv6. You have IPv4 firewall rules. They're not going to be able to get in. The firewall rule isn't going to be there.
It's totally independent. It's almost like I have two separate servers. I have an IPv4 server and an IPv6 server.
So I'm going to put up two firewall rules for the different.
Yeah. Yeah. So another unfortunate thing is IPv6 is a separate protocol. So that means if I have dual stack, if I have IPv4 and IPv6, I have doubled my work. All of my access control, all of my routing, all of my address management, all that stuff is doubled because I have to do it for both independently. So yeah, and I don't, anybody was around for the DECnet IPX days? Only a few? But yeah, okay, if you go back to the days when we had DECnet and IPX, yeah, you had multiple protocols, and yeah, there were definitely some interesting interactions between them, and we're gonna have that for a while. So, okay, DNS, this is just an example. The one thing I want to mention with DNS, a lot of protocols like HTTP, DNS, SNMP, SSH, they're oblivious. They don't care what the transport protocol is. They'll run over whatever. So I don't have to have IP, just like typically on a network, I can do like a host dig or NS lookup and get back a quad A record. I don't have to have IPv6 access to get IPv6 records. So this is an important point because some things do not deal well with this if you advertise stuff. If you advertise that something's accessible via IPv6, so just remember that. All right, and then here kind of quickly I give some examples. For whatever reason in Linux, instead of having a command that just automatically figures out which version to use, that's how they did it in most operating systems. For whatever reason in Linux and OS 10, they have separate commands. So you actually, a lot of stuff you have to add the 6 to use IPv6 version. Not everything, but for some of the troubleshooting ones. There's still some quirks. So another quirk is IPv6 literals. So because I have colon's a port delimiter. If I use just a straight IPv6 address, most things can't understand it. So in the literal form, I have to put square brackets around it. Okay. Right, in order to get it. So like if you're using a literal address in a browser with wget or something like that, you have to close it in brackets. And some things, just as an example, like curl, still can't deal with it. Curl I have to add a -G. So there's still, that's actually a good example, there's still some quirks that you run into.
Huh.
So hopefully this will save you some of the pain. Resources, the TLDP is not bad, a little dated. Lots of tunneling. So because the majority of the internet's still IPv4 only, there's lots of tunneling protocols. So I'm not going to go through all these, but I want you to be aware of them because let me tell you right now, most of you are already running IPv6 and you're just not aware of it. So it's good to learn about these guys. Okay, this is kind of more in the networking realm, but just to show you, there's a whole bunch of layer 2 issues and kind of relevant controls, so I just kind of throw this out there as reference. Sorry, this is in Cisco ASA format. I didn't get a chance to convert this to IP tables, but just as an example, this is what you should allow through on a transit device in order for IPv6 to function properly. But I did include, in this special publication, 800.119 is absolutely fabulous. It goes through all the security ramifications and compares everything with v4 versus v6. It's one of the best reads I've ever had for IPv6, and it's free. The link is right there. And then RFC 4890 goes through all the recommendations on firewalling for ICMP. Okay, so we're out of time, but I did include in here kind of like an example topology that you could do, and then how to get started. So in terms of, I don't know if you've heard of Hurricane Electric, but it's a way to get on the IPv6 internet for free if you can't get native access. It's pretty easy to set up. They have examples for all major operating systems, for Cisco, for Juniper, just about everything you can think of. I have some guidelines in here in terms of developing your addressing plan, what you want to do, the kinds of things you want to look at. Be careful about using that. And it just kind of walks you through. These are all the steps you would need to do if you want to look at a pilot or a lab or actually rolling out IPv6.
So that Hurricane Electric also has a training class available? I mean,
Yeah.
you can go through
Yep.
some training, and actually they'll help you set it up, and they can use their site to set one up and try it out and that type of thing.
Yeah, that's an excellent point. Yeah, and that's
The
all
O'Reilly book
free.
is good? The IPv6 book?
Yeah, so this is probably the best one for Linux from Sylvia Hagen. It's a little older, but it's still pretty good. A lot of this stuff, if you're on the security side, this is on the Cisco side, but it's pretty sweet because they talk about using Scapy to actually test everything. Because a lot of vendors will say, oh yeah, our support is perfect. But then you pull out, well, okay, let's pull out Scapy 6 and let's actually send attacks or send traffic and see how you deal with it. So they actually walk you through how to actually validate. And the validation you can use for anything. So that's pretty good for that. Does everybody know about Safari? Safari Books Online?
O'Reilly?
Yeah. So all of these are on Safari. If you've never checked out Safari Books Online, you should. You can do a free trial. I mean, it's the best thing you'll ever do. How many people have actually bought a book, and then they bought the 2nd edition, and the 3rd edition, and they get to the 5th edition, and they're like, man, there's got to be a better way. That's why you have Safari. Right? When I was getting a book for the 5th time, I'm like, this is nuts. So all this stuff is on Safari. It's all searchable. This is the NIST special publication, so these two are really good. I know this isn't a Microsoft crowd, but I will say that Joe Davies' book is absolutely fabulous. Unfortunately, it's all focused on Windows, but it's great because the guy has lived and breathed IPv6 for like 12 years, I think. So he knows it like nobody. So that's absolutely by far the best book I've ever read, because really to understand a protocol, really you have to understand the implementation, right? So you have to choose an operating system and just go through at a low level. How does it work? How do the IPAs work? How does routing work? How do sockets work? So I mean, this book is great. Unfortunately, there's nothing like that for Linux. There's lots of great blogs and articles, and you can read the RFCs.
Source code.
Or source code, yeah, you can read the source code. But yeah, source code, I mean, even just reading all the RFCs would probably take years. But hopefully that helps. And then I've only done 2 so far, but I'm trying to blog on packet pushers. And then I occasionally tweet, but this is a pretty good group. It's pretty vendor neutral. So, and there's been some decent IPv6 stuff. So I'll leave it with that. I put, if you're looking at getting connected at home, here are the options you want to go through in the order of preference. So I just threw this in the appendix. So these are basically all the things you want to go through. All of these are free. Obviously, you have to pay your ISP for access, but other than that, all these services are free. So it's not hard or expensive. Once you're on the internet, it's not hard to get IPv6.
You'll give me the slides.
Yep.
We'll put them up on the website as soon as
And then if you have to deal with Windows, here are the Windows commands. And I guess one other thing that you just don't have time for, but just kind of file this away in the back of your head, is prefix policies. So if I have multiple protocols, how do I pick which protocol I use? If I have multiple addresses, how do I pick which source and destination addresses I use? That's what prefix policies do. So I only showed the command, I only showed the command, unfortunately, maybe I'll make a point of adding it for Linux too. All